know where black holes come from. Well, we know where the smaller ones come from, the stellar mass black holes that form at the end of a star's life, but the big ones, the ones that are hundreds of thousands to billions of times the mass of the sun, how those form is kind of a mystery. And yet they are everywhere. Pretty much every big galaxy has a supermassive black hole at its center. Luckily, black holes can grow over time, either through eating up gas or merging with other black holes, so they don't have to start out as big as they are in today's universe. But they have to start somewhere. They have to start with a seed, and we typically break those seeds into light and heavy. When I say light, I'm talking astronomical terms. They can be up to 1,000 times the mass of the sun, but they're the small ones. An example of a light seed is a star that reaches the end of its life and collapses. It's thought that in the early universe, stars could get bigger than they can today because there weren't as many metals or elements heavier than hydrogen and helium in the gas that stars formed from. So they could get up to 1,000 times the mass of the sun, much bigger than any stars that exist today. The problem with light seeds is they would have to be able to grow really, really quickly. Using telescopes like JWST, we are discovering black holes that are pretty big very early in the universe. These black holes are nearing 1 billion solar masses only about 700 million years after the Big Bang. And if you consider even very generous models for how quickly black holes can grow, it's quite difficult to get them down into this light seed range. So instead we have to think about heavy seeds. These could form from the collisions of a lot of smaller stars or smaller black holes, or they could come from so-called direct collapse, where a big cloud of gas collapses directly into a black hole without first becoming a star. The issue is simulations of these formation pathways give somewhat mixed results on their feasibility. And even still, to explain those observations, these heavy seeds would have needed to form really early on, a couple million years after the Big Bang. One final possibility are primordial black holes, which would have formed in the first seconds of the universe's existence and had masses ranging from tiny to thousands of times the mass of the sun. But there's a ton of uncertainty about those things. So yeah, there's a lot of possibilities for what seeded these supermassive black holes, but we just don't really know. As our simulation techniques improve, we're getting a better understanding of what's theoretically possible. And as our observations improve, both from telescopes like JWST and from gravitational wave observatories, we're getting a better sense of what might be happening and when. But where supermassive black holes come from is still very much an open question.